next thing I want to discuss is the multiplication principle. So we're going to talk about tree diagrams. I'm going to introduce the multiplication principle, and then we're going to generalize it. So a tree diagram is the way to show possibilities for an event having choices along the way. So suppose a rat gets in a maze at point A. There are 5 possible routes to get from route A to route B. And then from route B to route C, there are 3 destination points. So there are possible paths, A, B, C, 2 ABC, 3 ABC, 4 ABC, 5 ABC, right? So there's 15 possible paths that the rat could take. And we've represented this with a tree diagram. The multiplication principle says, suppose that a task is composed of 2 consecutive choices. If each task can be performed, if choice 1 can be performed in M ways, and choice 2 can be performed in N ways, to complete the task, it can be performed in M times N ways. So suppose a rat in a maze starts at a point A. There are 5 possible routes to get from point A and 3 possible routes to get from point C. How many possible ways are there for the rat to reach point C? We're going to take 5 times 3, which is 15, which is what we just found when we looked at this beautiful tree diagram, right? But this way we don't have to draw an entire picture. We can generalize this to multiple events. There could have been an even longer maze for a rat, and many choices there were. We just keep multiplying and multiplying. So let's work through a few examples. How many different outfits consisting of a coat and a hat can be chosen from 2 coats and 3 hats? So that would be 2 times 3, which is 6. How many 2-letter words, including nonsense words, can be formed if repetition is allowed? So I have how many choices for my first letter? There are 26 letters in the alphabet. And then for my second letter, I have another 26 choices. So I have 26 times 26, which is 676. So I have 676 possible words. Now, this third question requires a little bit more thought. So how many 2-letter words, including nonsense words, can be formed if repetition is not allowed? Okay, so I have how many choices for my first letter? I have 26. And how many choices do I have for my second letter because repetition is not allowed? I have 25. And 26 times 25 is 650. Now, what if I wasn't feeling super confident about this? Well, I know that any 2-letter word, including nonsense words, can be formed. I'd have 676 of them. So I'd have AA, AB, ... all the way to AZ. Then the pattern repeats again. I have BA, BB, ... BZ. You can see here I have a 1 letter with repetition. It's going to happen every single time all the way to ZZ. So because it happens once for every letter, it's going to happen 26 times. Well, 676 minus 25 is 650. I can't write today. 650. So either way, we would have ended up with the correct answer. What if I have 2 coats, 3 hats, and 2 scarves? How many different ways can my outfit be made? So I've got 2 times 3 times 2, which is 12. Okay, next, an exam contains 5 true or false questions. How many ways can the exam be completed? So think about it as how many choices do I have for my first answer? right? Here's my quiz. How many choices do I have for my first answer? I can have true or false, right? That's 2. I have 2 choices for my first answer, true or false. I then have 2 choices for each answer after that. So it's going to be 2 to the 5th, which is 2 times 2 times 2 times 2 times 2 times, oh, I wrote too many 2's. 2 to the 5th, which is 32. This problem's a little more complicated. It requires us to be able to factor. That's something we learned in college algebra in chapter 5, but I haven't specifically covered in this course. So this is just to kind of push you guys a little bit. Don't spend a lot of time learning how to factor if you don't, okay? I'm not going to have it come up in this course. I just wanted to show you guys an example. So if you can elect a club president and a vice president in 506 ways, how many members does your club have? So all I know is I have so many choices for my first, right? I got to pick a president. But then the president can't also be the vice president. So I have that many choices minus 1. And I should probably pick a variable, huh? How about x? So here I have x times x minus 1 equals 506. I'm going to go ahead and multiply this together and set it equal to 0. Then I can factor. What are the factors of 506, that negative 506, that add up to negative x? Well, that's going to be negative 23 and positive 22. That means I get that my x value is 23 or negative 22. Now, you can't have negative 22 members of your club. So sorry. So our answer here is 23 because it's got 23 choices for my first. We take away 1, we've got 22 for the second. 23 times 22 does give me a positive 506.